All right, hello, welcome back. Um, so in this video, I'm going to actually go over how to solve for a bond's yield to maturity. In reality, it's rare that any sort of bond trader or investor is going to have to solve for the bond's price, usually because the price of the bond is usually quoted. People are uh, it, they're going to quote the bond price, right? When one person sells it to another, they're going to be actually thinking in terms of dollars, and it's kind of up to the whoever's buying or selling it to, calculate the yield to maturity themselves. So this is actually pretty important. The problem is that there's no real algebraic or analytic way to calculate yield to maturity. Kind of like what we saw with the annuities. It can be kind of cumbersome, so there has to be we have to use a sort of algorithmic approach to find the yield to maturity. But fortunately, Excel has functions, and two functions in particular: the rate function, which we've already been over, but we'll apply it now to bonds, and the yield function, which, like the price function, is a bond-specific type of function. All right, so let's go ahead. I have these two examples here. They're both one. They're basically the same example, except one's semi-annual. So we have a U.S. Treasury bond that matures in 21 years. Currently trades for a price of $833.40. The Treasury pays a 7% coupon rate paid annually on a $1,000 par value. That's typical. What is the bond's yield to maturity? Okay, so we'll start with the rate. So right under annual, we'll go equal sign rate, open parentheses. And the first thing we need to do is number of periods. So there's 21 years, and it's number of periods is 21 since it's paid. We're assuming for right now it's paid annually. The payment is 70, comma. The price is 833.4. Now here's an important thing. When you put in the price in for the present value, like we've talked about previously, you have to put it in as a negative since you're paying for it. It's an outflow. So 833.4, and then comma, and then future value is going to be 1,000. All right, as we've seen before in the last video, because that's the future value of a bond is 1,000, and then the type is 0 because it's basically the annuity portion of the bond is an ordinary annuity. And good guess is always to start off with the coupon rate. All right, so we'll do the coupon rate, 0.07. Okay, we'll close that parentheses and we'll see. Okay, the yield to maturity on this bond is 8.762%. And that should make sense, right? That the yield to maturity is higher than the coupon rate because the price of the bond is less than the par of 1,000. Okay. All right, now let's go about doing the semi-annual one. It's going to be very similar. We'll just do equal sign rate, open parentheses, number of periods. So that's down here, right? Number of periods, of course, there's two semi-annual periods per year, and it's a 21-year bond, so that means there's 42 periods. So do 42 comma. Now that 7% coupon rate, that is the annual coupon of $70 is going to be divided across two periods. So it's going to be split across two periods, two semi-annual periods. So 70 divided by 2 is 35. So comma, price, we still put negative 833.4, comma, par is still 1,000, type is still 0, and a guess, we'll stick with a guess of 0.07, right? All right, now notice we get a semi-annual rate of 4.373, but notice this is the yield to maturity on a semi-annual basis, so every 6 months. So to get the yield to maturity, we actually just take this. Notice I put a little per year here. We take this and just multiply it by 2, okay? And that will give us our yield to maturity. Notice it's not going to be that different from a yield to maturity on an annual basis, but it's, it can make some difference, okay? All right, now notice that this is also not this is not a this percent right here. This is not an effective annual rate. You can actually find the effective annual rate on this, but that's it's just the yield to maturity. Yield to maturity is usually not quoted as effective annual rate. Okay. All right, so that's how to solve it. That's pretty simple on the rate function. If you want to use the yield function, it's a bit trickier, but it's also, it might have some, in terms of, if you don't know, if you make a mistake on, say, the frequency, it's easy to fix. All right, so I'm going to go here. I'll do equal sign, and it's just equal sign yield, right? And then we'll open parentheses, and just, again, we have a settlement date, a maturity date, a rate, that, in this case, rate is the coupon rate, not the yield to maturity. PR, that stands for the bond's price. Redemption, again, that's 100 unless you expect it, there to be some default, which we're not. Oh, ignore that, sorry. I need to get that fixed. And then frequency, number of periods it pays, and then of course the basis. All right. So let's go back and find our settlement. So we know that this bond is 21 years, right? So we know to just choose a settlement date. So I'll choose. Let's see. And remember, when we use this date, we have to use a date function. So equal sign date, open parentheses. I'll choose 2023, comma 10/2, right? October 2nd. 2023, right? And then maturity date, I'll do equal sign. It just has to be the same date, but 21 years later. So I'll do date, open parentheses, 2023, plus 21, comma, October 2nd. Okay, so in 2020, so from 2023 to 2044, excuse me. And again, the rate is it's just the coupon rate, which is 7%. So we'll do 0.07. I don't know why I put it in percentage like that. I'm going to ignore that for a second. Sorry about that. 0.07. There we go. The price. Now, the price doesn't have to be negative. It actually shouldn't be negative. Don't put the price in as if you're going to use a yield function, don't put it as negative. But there is something else you do have to do. You have to put it as a percentage of the par. All right. So basically, you have to take, you have to take the whole price, divide it by whatever the par is, and then multiply it by 100. So that's how it wants it to be put in there. So it would be, in this case, that's going to be 833.40, right? Divided by the par, which is 1,000, and then times 100, right, to give you a percent, right? So this price of $833.40, since the par value is 1,000, that means the price is 83.34% of the par. All right. So we need to put it in as a percentage of the par. Okay, and and don't use the percent function for that either. Just use as a 83. You don't need to put a percent there, but it needs to be calculated as a percent. So to you need to understand it as a percent. Redemption is just 100 still. Frequency, we'll start off with annual, and then basis, again, we'll just use the American version. So now we'll do equal sign, yield, open parentheses, click the settlement date, the maturity date, the rate, the price, the redemption, frequency, and the basis. And close parentheses. And we get the same thing for a yield to maturity, 8.762%. And notice that if we change this frequency to 2, we'll get our, the yield to maturity will fall because it'll go to the, it'll go to the semi-annual yield to maturity. Okay. All right, so that'll do it for this one, and you'll hear from me again. All right, bye.